Hi everyone, welcome to Javaras. In this video, we are going to look at Proof Key for Code Exchange or PKCE in short. PKCE is an extension to Authorization Code Grant Flow in order to protect the applications from CSRF and Authorization Code Injection attacks. You know that there are multiple types of flow in order to get the access token. So for example, Auth Code Grant Flow, then another is implicit grant flow, then another is let's say client credentials, then another is user credentials. So actually we don't use user credential, but there are like few more flows. But PKCE is useful for authorization code grant flow only because this flow contains two steps in order to get the access token. In the first step, the client sends the user to authorization server, and then authorization server sends back authorization code to the client. And in the second step, the client sends the code back to the authorization server, and then authorization server replies with access token. The first step is called authorization request step, and the second step is called authorization code exchange step as well. Now let's see how PKCE provides the protection against CSRF and authorization code injection attack. Now what do we mean by authorization code injection attack? If someone intercepts our authorization code and if they make request with that code to the authorization server, and let's say they know the client ID, redirect URI, and these things, then this will be able to get the access token, but we don't want that. Now initially the PKCE extension was developed for mobile devices to provide them more security for OAuth2 flow, but later it was adopted for web application as well, and after that it was adopted for confidential client as well, because confidential clients are also vulnerable for authorization code injection attack. Now let's see how PKCE provides authorization code injection attack. So here I will again draw these two steps. So in the first step, here we have client and here we have auth server. So client will send one request. It will not directly send the request to auth server. It will redirect the user to authorization server. And that endpoint is called authorization request endpoint. And in order to redirect user there, the client sends some query parameters, which we have already seen in the previous videos. So let's say client ID, redirect URI, and few more parameters. Now the important parameter for PKCE flow is code challenge. Code challenge. And the another query parameter is code challenge method. So these two are important parameters for PKCE. And after that, client will get the authorization token back. And in the second step, again I will draw client here and authorization server here. Now client will send a few parameters in order to get the access token. So that will be client ID again. Then let's say authorization code. Now it will send one more parameter, which is code verifier. Now using this code verifier and this code challenge and code challenge method received earlier, the authorization server will validate whether this token request is coming from the same client which originated the authorization request or not. If not, then authorization server will deny this request. Now we will see that how the client generates code verifier, code challenge and code challenge method, and how authorization server verifies these parameters. The first thing which the client needs is code verifier. So what is code verifier? Code verifier is cryptographically secure random string, and its length should be from 43 to 128 approximate. And what are characters we can use are capital A to capital Z, small a to small z, 0 to 9. That means alphanumeric characters. Also, four other characters are allowed, which are underscore, this hyphen, then period or dot, and one is this tilde. So these are all the characters which are allowed in this cryptographically secure random string. And this is called code verifier. Now we have the code verifier. Now we will create a hash of code verifier using SHA-256 algorithm. After that we will do base 64 URL encoding, and after that we will get the code challenge. Okay. Now in some devices it is not possible to generate this hash or this SHA-256 hash. So it is very rare, but sometimes it is not possible to generate. In that case, the code challenge will be equal to the code verifier. So the code challenge will be code verifier only. So, but you should not do that, because if you do that, then there is no security of the PKCE. But if, let's say, authorization server enforces you to use PKCE, but there is no way to generate hash, in that case, you can use the code verifier as code challenge. But in this case, the code challenge method, I will just say method, the code challenge method will be plain. So this method is this one, this code challenge method, which we send in the authorization request. But if you are able to create hash and base64 URL encode it, then the method will be as 256. So we need to tell authorization server which methods we are using in order to generate the hash. Either we are using SHA-256 or we are using plain. That means we are not creating hash or encoding of the code verifier. That means code verifier and code challenge are same. So this is the first step. Now in the second step, we need to send code verifier with the token in the token request. And code verifier we have already generated that here, so we can send that. So now we need this code verifier. So what we can do is we can store this code verifier in local storage or session storage, and then we can send it in the token request. So that is the part at the client side. Now we will see what the authorization server need to do. Now here also we have two parts. One, when the authorization server receives a auth request. So this auth request contains many parameters: client ID, client secret, if it's a confidential client, redirect URI, many other parameters, and two important parameters are code challenge. So I will just call it challenge, and code challenge method. I will just write it method. Now it depends on the authorization server. So let's say authorization server mandate the PKCE for all the clients. In that case, these two parameters should be or must be present in the request, otherwise request will be invalid. Sometimes authorization server enforces the PKCE flow only for public client or mobile client. In that case, since authorization server know using client ID whether it is confidential client or it is a public client, in that case it can enforce the PKCE. So in that case, this challenge cannot be null. So this should not be equal to null, and this method should be equal to as 256 or plain. So it depends on the authorization server. So in this stage, now authorization server needs to store this challenge somewhere, this challenge and this method somewhere. So what it can do is uh, it can store these two things along with the authorization code itself. So in the authorization code, it will store this code challenge and code challenge method, and then it will encode the authorization code, and it will send that authorization code back to the client. Now in the second step, this is token request. In the token request, what will we get is we will get the authorization code, we will get client ID, redirect URI, but I will not go over there because that we have already covered. We will get the authorization code and we will get the code verifier. So I will just call it verifier. Now we will, so this code is obviously encrypted. So we will decrypt it. Then we will get the actual authorization code. And using this authorization code, we will get the challenge. So if you remember, we put this challenge in the authorization code in the first step, and we will get the method as well. Now again, it depends on authorization server. If it enforces the PKCE or not, so it will verify that this verifier should not be null. And now based on this method, so let's say method is S256. That means this verifier was hashed using SHA-256 in order to get the challenge. So what authorization server will do is it will hash it using SH256 or SHA-256, and then it will create base 64 URL encoding, and it will match this with this challenge. So both of these should be equal. But let's say the method is plain. That means the verifier and code challenge, they should be equal. If they are not, in that case, we will invalidate the request and we will deny it. So these are this is the flow of proof key for code exchange extension in the authorization code grant flow in order to get the access token. Now okay, yeah, there is one more thing. Like let's say the client implements the PKCE, but the authorization server does not implement PKCE. In that case, it will work because the additional parameters sent by client will be ignored by the authorization server. And if client does not support PKCE, but authorization server supports PKCE, then it depends on authorization server whether authorization server enforces the PKCE or not. If it is enforces the PKCE, in that case, client needs to implement it. Otherwise, if PXE is optional, then if client does not support, then also it will work. But you will not get the security of PXE mechanism. Now let's implement this PXE flow in the code. So I have already mentioned that the PXE flow is important for both public client and confidential client. But in this video, we will just use public client to implement the PXE flow. But in the GitHub repository, you will find that for both the clients, public client and confidential client, the PXE flow will be implemented. This is the Auth2 directory. So here we have authorization server, confidential client, public client, and resource server. I opened this public client SPA in Visual Studio Code. So here if I go to util.js, so this is the file where we are creating this authorization URL. So here we need to include code challenge and code challenge method in the URL as well. So let's do that. Let's create a method to generate the code verifier. Const generate code verifier. This will not take anything. Now what it will do is this method will call another method which will generate a cryptographically secure random string. So let's just return generate secure random string, and let's say we want the length to be 64, and we need to tell one more thing. So first let's create this method const generate secure random string, and it will take two things, the length, and default value is let's say 10, and it will take the lake. So lake means the available or the allowed characters from which we want to generate the random string, and its value will be let's say default lake. Okay, I guess we need to put arrow here. Okay, Now we have this method. Now we have already discussed that the allowed characters to generate this string are this one. So these characters are included in the default deck. We need to include 4 more characters. So it will be default leg plus 4 characters, which are hyphen, underscore, then period, and then this tilde. Okay, now we have called this method. Now let's implement this method. So we cannot directly create the cryptographically secure random string, but what we can do is we can create byte array of cryptographically secure bytes. So let's do that, and those will be as indexes in that lake. So I will say const indices will be new uint at array, and its length will be the given length. Now there is a library in JavaScript, or there is a method. So this is like built-in method, which is crypto.getRandomValues. Crypto.getRandomValues, and it takes an array. So I will just give this array, and it will fill this array with securely generated values, and we will have the securely generated bytes. Now let's initialize a variable to empty string, and for, let's say, let index of indices. So we have this index and result plus equal to lake and index mode lake dot length, and let's return the result. So now we have the result. So this is the cryptographically secure generated string with length 64, and these are the available or allowed characters. So we have the code verifier. Now we need to create hash of this code verifier, and then we need to encode it using base64 URL method. So first of all, I will create a method which will create the hash and encode it. Generate hash equal to, it will take a string. So I will call it plain text, and this will return a promise. So it will be async. First of all, since we have this text, so this is a string, we need to convert this in byte array. So let's do that. For that, we'll say const data will be new text encoder dot encode and plain text. Now we have the data, and we can generate hash. Const hash will be await window dot crypto dot subtle dot digest. So this is a method to create hash. We need to give 2 things. First, the algorithm. So let's take the algorithm as parameter as well. I will provide the algorithm here. And the second thing is the data. So we have the data here. Now we have generated the hash, but hash is in the form of array buffer. From the array buffer, we need to convert it in byte array. Let's do that. Const hash array will be new uint at array, and we will provide the hash. Now after that, this is the byte array. We need to convert byte array into the text. So for that as well, we can use string dot from char code method. So const hash string will be string dot from char code dot apply, and let's give null, and then the array. So hash array. So we have the string here. Now we will encode this in base64 URL format. For that, I will create another method here, const base64 URL and code, and it will take few things, data, and it will take one more thing, whether we want to remove the padding or not. So remove padding and its value is false. So padding means if you see any string which is base64 URL encoded, then there will be some characters, these equal characters at the end. You will see like this. So those are padding. So we don't want that. Then remove padding will be true. There is already a method which base64 encode. So let's call that method. Result will be btoa and data. But this base64 encode, it does not encode using base64 URL method. So in order to do that, we need to replace all plus signs with minus signs and all divide signs by underscore. So let's do replace. So I want to replace all the plus signs. For that, we can use this pattern plus g, and let's replace them with hyphen. And again, I will replace all these slashes with underscore. We want to replace all with underscore. Now, if we want to remove padding, in that case, we can replace all that equal signs with empty string. So result will be result dot replace so we want to replace all the equal signs which are at the end of the string. With the empty string, and let's return result. So this method base64 URL encode and this method generate has. So let's call this method. Then the data will be has string and remove padding will be true because we want to remove the padding. So this method generate has, and we need to call this method in order to generate the code challenge. So const generate code challenge, and it takes code verifier. Code verifier. So this will be a sync method because it uses the generate has method. So let's return has, and generate has text, plain text, which will be code verifier, and algorithm which will be SHA 256. Now we have code verifier and code challenge. We have the methods. Let's use those methods. Now we will use those methods here. So since we will use this generate hash method, so this will be async method. Let's do that. So we have code challenge here. Let code challenge, and this is the code challenge. And one more thing, let code challenge method equal to. So these are the default values for code challenge and code and this one. So the default value of code challenge is code verifier, and default value of code challenge method is plain. That means let's say if we are not able to calculate the hash, in that case we will not do anything. But if we are able to calculate the hash, in that case the method will be as 256. And now instead of directly returning the URL, what we will do is URL plus equal to, okay, so the first thing is and code challenge equal to code challenge URL plus equal to and code challenge method equal to code challenge method, and we will return the URL. So this is how we implement PKCE. Now we can, what we can do is we can extract this in another uh, method if we want, but let's keep it right here. So this is the first part of the client. While creating the authorization request, we are sending code challenge and code challenge method. But now while creating the token request as well, we need to send the code verifier. So let's do that. And we are doing that in OAuth callback. So here what we will do is, okay, and if not code, then this else if else fetch access token from authorization server. So here we are doing fetch access token. Let's go here. This is the access token URL, generate access token URL, and let's make it await. Oh no, like we can, what you can do is, so first of all, let's go to main method here, and here we are calling this generate authorization URL method, but this is async method. So what we need to do is generate authorization URL, and then we will get the URL, and we need to do something with this URL. So what we will do is we will do this. Okay, so that is it. And now let's go to OAuth callback. We need to generate access token URL. So let's go to this method, and we are just returning token endpoint. Okay, that's fine. Now in the URL search params, we need to include one more thing, which is code verifier. Code verifier, and its value will be locally storage dot get item, and the value name is code verifier. But if we see here, okay, we are clearing the local storage here, but instead of clearing it here, we can clear it here, because if we clear local storage before getting this item, then the value of this will be null. This should work. Now if we run it, then it should work. There should not be any problem, because the additional attributes will be ignored by the authorization server. So we can try that. Well, let's try that. First of all, I will run this server. First of all, let's run authorization server, but for that we need to run the Docker, because authorization server needs database access, and the database will run in Docker. So I have started it. Let's go to authorization server, Docker compose up D. So the database is up and running. Gradle W boot run. Okay, it is running. Meanwhile, I will go to public client SPA, and here as well I will start the server. So for that we can use Python 3 m http dot server, and port is 5000. Okay, this is working, and here I will just go to localhost 5000, and we can see this connect your account. I will go to inspect here, and if we click on connect your account, then we can see that code challenge is object promise and code challenge method is s256. So we need to change it. Why are we getting object promise something here? So let's do that. So again, I will go to util.js here and generate authorization URL. Have await here. Save it and restart it. Now I guess it will work. If I click here, then I think we should be able to see it, the code challenge and everything, or we can see it in the networks tab. In the net, this is the request. In the payload, we can see code challenge is this one and code challenge method is S256. So if we just log in here and sign in, it's asking for these three permissions only because we have not included that contact.read and contact.write here. But if we click on allow, then we can see this is the access token. So this is working. So as we have already seen that even if the client implements the PKCE flow, but authorization server does not support it, in that case also it will work because authorization server will just simply ignore the additional parameters. Now we need to implement this flow in authorization server as well. Let's do that. Now we need to implement two things in authorization server. First, while handling the authorization request, it needs to store the code challenge and code challenge method in the authorization code. And in the second step, it needs to validate the token request. So first of all, let's go to source main Java, and in the authorizations package, we have authorization code. Or let's go to auth request. So first of all, in the request itself, we will get two more things, code challenge and code challenge method. So let's put them here, string code challenge and string code challenge method. Now let's go to authorization controller. So this is the error because we need to get two more things from the query. So let's do get them. Query dot get. First is code challenge. Then the second is code challenge method. Now the authorization server does not need to validate anything here. It just need to save these things in the authorization code. So let's go to authorization code, and here as well we need those things. After ID we have code challenge and code challenge method. So we have these two things. Now we are getting some error here. So we will get these also as a parameter to this static method. So we will have string code challenge, string code challenge method, and we will just pass them here. Code challenge method. Now, okay, we have some problem here. We will fix them. So let's fix them first here. So now here, what we are doing is to string we are doing this here, like we are separating all the parameters using double hash, and then while creating authorization code from string we are splitting the string using double hash. So I don't like this approach. So what I would like to do is I would like to convert this authorization code in JSON representation or in JSON string, and then while deserializing it as well, I will try to convert that JSON string into authorization code object. So let's do that. For that we will need one new object mapper. I will create a new object mapper. Object mapper, object mapper will be JSON mapper dot builder dot add module. Since we are dealing with local date time here, so for that we need to add one module here, and the module name is Java time module. Let's new Java time module, and after that we will just build it. So we have object mapper here, and now let's return object mapper dot write value as a string, and the object is this. That means this authorization code, and we have try guys here. We will surround it with try guys, and we will return runtime exception if anything goes wrong. Now the next thing is we need to convert that JSON string back into the authorization code. For that as well, we will use the same object mapper. So what I will do is I will extract it in a method. Okay, so get object mapper. So let's do that. I will remove everything here. What, what, yeah, we have this static mapper. Okay, so we can inline the variable. That is fine. Let's remove this thing. Now let's get the object mapper. So where object mapper equal to get object mapper, and using this object mapper we will create an object of this authorization code class with the given this string code. Let's say return object mapper dot read value. Then we need this string, so this string is code, and then the type of the object, which will be authorization code dot class. And again we will need to handle some exception surround with try catch, and again we will return new runtime exception. So that is it. So we have completed things here. Now we have two related problems. Let's go to the first related problem here. So okay, we are getting problem in test encode decode auth code. So code challenge will be, let's just say ABCD, and code challenge method, let's just say S256. Let's run this test as well, whether it passes or not. The test is failing, and the reason is, okay, we need to solve this error as well. While generating the error, while generating the authorization code, we need to give the code challenge, and that we can get from the auth request. Auth request dot code challenge and auth request dot code challenge method. Let's rerun the test, because running the test is very important, and this test is failing. Okay, so the expected and actual both are same, but okay, I guess because when we are converting that JSON string back into the authorization code, then it is not considering that list of scope as a set, it is considering them as a list. So we can just say list here, list dot off, and let's run it again. Okay, so this is working. So now the first step is completed. Now authorization server is able to get the code challenge and code challenge method from the authorization request, and it is able to put them in the authorization code. And after encrypting the authorization code, it is sending that back to the client. Now what client will do is client will send back that code with the code verifier. Now this is the main part of the authorization server, where we need to verify whether the code verifier which we are getting on the token request is for the code challenge which we get earlier in the authorization request. Now we need to go to the token request. So I will go to token package here, and we have token request here. This is the token request. Now in the token request we will get one more thing, which is code verifier. So let's do that, string code verifier. And so once we did that, we will get some errors. So this is the error. Now we can just say query dot get code verifier. Okay, now if we run this test again, okay, now there is no compilation error or anything, but still we need to verify whether this token request is correct or not. So let's go to verify code. We need to verify the code verifier or code challenge. The PKCE is not enforced. If the client is trying to use it, then they can use it, otherwise it is fine. If authorization code dot code challenge method, or sorry, code challenge, if code challenge is not null, only then we need to verify the code challenge. Okay, now let's see what is the old hash. So that is nothing but the code challenge, but still we will store that in a variable old hash. will be authorization code dot code challenge. So this is the old hash. Now we need to create a new hash. So let's do that. String new hash. So first of all, what we will try to do is we'll just treat the code verifier as a new hash. That will be token request dot code verifier. So this is the new hash. Or what we can do is, let's say we can just make it null. We will check what is the value of code challenge method. Authorization code dot code challenge method. If it is equal to as256, but I will change it to object dot equals. Objects dot equals. The first object is authorization code dot code challenge method, and the second object is plain. In that case, new hash should be equal to the token request dot code verifier. Otherwise, if it is equal to as256, now that means we need to create the hash of this code verifier using SHA-256 algorithm. Now for that, I will create a new util class. So let's create a new Java class and I will call it SHA util. And here I will use that class. So I will say new hash will be SHA util dot SHA-256 SHA-256 hash of the token request dot code verifier. Okay, now we have not created this method yet, but we will create that soon. If not objects dot equals old hash and new hash. If they are not equal, in that case we will throw invalid token request exception. We need two things: error code and error description. The error code will be invalid request and the description will be code verifier is not valid or correct, whatever. So we will throw this exception. Now let's implement this method. Create this method. Okay, so we need to create SSH256 hash of this plain text. Now generally we create hash of byte array and we return byte array. So let's create that method first. So I can say private static byte SHA-256 hash. It will take byte array and let's say plain bytes. Now we need to create message digest. Message digest will be message digest dot get instance, and we need to provide the algorithm name, and algorithm name is SSH256, and we need to handle this exception. So let's add exception to method signature. We have message digest and message digest dot update. We will update with the data which is plain bytes, and let's return message digest dot digest. Okay, so we are creating hash of this byte array, but here we already know that we need to create the hash and then we need to encode using base64 URL encoder. So let's do that. So first of all, from the string we will create byte array. Hash will be SSH256 hash which accepts byte array, and byte array will be data dot get or plaintext dot get bytes, and this is the encoding which is UTF-8. Now we will get the hash and Let's just do this as add exception to method signature. Now after that, base64 dot get URL encoder. So in Java, mm, encoding using base64 URL for URL and method is very easy. So there is a class base64, and using that we can get the URL encoder. Either we can just get the encoder, so dot get encoder, or we can get the URL encoder. So we are getting URL encoder, and we want to remove all the paddings as well. So we can say without padding, and then we can encode to string hash. So that is all we need to do. Now here we need to handle that exception. So let's run with try catch. So if we are unable to um, do that, then also we will return this error. Okay, save it. And if we go here, there is no error. I hope. What is this error? Missing return statement. Okay, we need to return that. Let's return this string. Hmm. Now let's rerun the authorization server. So that is running here, but we will return it, rerun it. Okay, so this is working, and this is running here. So let's open new incognito window and go to localhost 5000. Okay, click on connect your account, username, and then this is password. Now if we go to, I guess, application, then local storage, then we should be able to, okay, we cannot see because we are in localhost 9000. But if we go to localhost 5000, then we can see in the local storage there is this code verifier. Now what we will do is, let's delete this code verifier. I will just delete it and click on sign in, allow, and we are getting invalid state. Now why are we getting invalid state here? Okay, because when we opened it here, it changed the state. Okay, no problem. Let's open that again. Localhost 5000. Now let's go to application. Now here we will remove this code verifier. Now let's click on connect your account, allow. You can see access token equal to undefined, because we are throwing that exception. If you go to network here and go to token here, preview, response, or header, we are getting bad request. Now let's go to application tab and remove this access token. So I will delete it, and I will go to localhost 5000 again, connect your account, and let's log in again. Click on allow. Okay, now we can see we are getting access token back. So that is how PKCE flow works for authorization code grant flow. So you already know that there are two steps for authorization code flow. In the first step, client sends authorization request to authorization server, and along with other parameters, we include two more parameters, code challenge and code challenge method. And in the token request, along with other parameters, we send one more parameter, which is code verifier. Now code challenge is hash of code verifier. If hash of this code verifier, which is received by the authorization server, is same as this code challenge which was received earlier, that means the same client or same server is sending both the requests, because there is no way that someone else can generate another input which has the same hash. So that is how it works, and we have implemented that in public client application. as well as in authorization server. You will find the code in the GitHub. There it is implemented in the confidential client as well. So I hope you liked the video. Please like, share and subscribe to my channel. I will meet you in the next video. Thank you everyone for watching it. Bye.